Hello everyone. In this video tutorial, I will discuss about subspace or vector subspace. Vector subspace, or simply known as subspace, is a topic from linear algebra. What is subspace? Subspace is nothing but a subset of a vector space denoted by capital V. But the first condition to be a subspace is the subset of the vector space should be non-empty. Consider as a field of scalars. This be a field of scalars denoted by capital F. A subset or a vector space, not subset, a vector space capital V is defined on this field capital F. Now what is vector space? Vector space is also a set of vectors which satisfies few conditions related to the elements of V and F. Now come to the next condition or next concept. What is subspace? Subspace is nothing but a subset. Subspace is nothing but a subset of the vector space. This subset should be non-empty. This subset should be non-empty. This is our first condition. The subset should be non-empty. The subset should be non-empty. This is our first condition. Now we consider any two arbitrary elements alpha and beta. We consider any two arbitrary elements alpha and beta from this subset so that alpha plus beta also belong to the subset. Let this subset be denoted by capital S. Okay, this subset be denoted by capital S when I consider any two arbitrary elements alpha and beta of S so that alpha plus beta belongs to capital S. This is our first condition. And our second condition is, suppose alpha belongs to S and C be any scalar belongs to capital F. Then C alpha belongs to capital S. Okay, then C alpha belongs to capital S. So this is our two important conditions to be a subset, a subspace. First condition is for any two arbitrary elements alpha and beta belongs to the subset S, then alpha plus beta also belongs to S, and if alpha belongs to S, that is the subset, and C be any scalar from the field capital F, then C alpha also belongs to capital S. So whenever we have to verify whether a subset capital S is a subspace or not, first we consider any two arbitrary elements alpha and beta from the set capital S. We then verify whether alpha plus beta belongs to S. If it holds, then we come to the second condition, that is alpha belongs to S and C belongs to capital F, that is set of scalars, implies C alpha belongs to capital S. Okay, but first we have to consider whether the set is non-empty or not. If the set is empty, then the conclusion is that the set cannot be a subspace, because to be a subspace the set should be non-empty. These two conditions can be written as a one condition like this. Say alpha comma beta belongs to S and and C, comma D belongs to capital F. Then if then if then if C alpha plus D beta belongs to capital S. So this is another condition, or you can say these two conditions can be made as one condition like this. But in problem related purpose, we have to follow this condition, these two conditions. Okay, so first we follow this condition. If the first condition holds, then we go to the second condition. If the second condition holds, then we conclude that the given subset is a subspace. So what is subspace? Let capital V be a vector space. Let capital V be a vector space over the field capital F. A non-empty subset, this is very important line. Okay, a non-empty subset, this is our very important line. A non-empty subset, a non-empty subset, a non-empty subset W of V is called a non-empty subset. W means W is a subset of the vector space V. A non-empty subset W of V is called a vector space or a linear subspace or simply a subspace of V if W itself be a vector space over F with respect to the same composition as defined in V. So the conditions are: a non-empty subset W of V is a subspace of V if and only if W is closed with respect to addition. That is, if alpha comma beta belongs to W implies alpha plus beta belongs to W for all alpha beta, and W is closed with respect to scalar multiplication, that is alpha belongs to W and C belongs to F. F means the set of scalars, or you can say field. Then this together implies C alpha belongs to W for all alpha. Okay. Now these two conditions can be made as one condition like this: alpha comma beta belongs to W, C comma D belongs to F implies C alpha plus D beta belongs to W for all alpha comma beta. So this is our main conditions. If the subset, if the non-empty subset, if the non-empty subset holds these two conditions, then only we can say that the non-empty subset of V is a subspace of V. Now come to some examples. This is our first example. Show that W equals to XYZ belongs to R3 such that X minus 4Y plus 3Z equals to 0 is a subspace of R3. Okay, so this is the condition of the set. Okay, so to be a member of the set, first we have to verify whether an element holds the condition of the set. Means this is a very tricky concept. If any element belongs to the set, then we can say the element should satisfy the condition of the set, and if any element satisfy the conditions of a given set, then that element should belong to the given set. Okay, so first, given W equals to this, since 0 belongs to R and 0 0 0 belongs to R3, and we also see that in place of X Y Z, if we put 0 0 0, the condition holds or satisfies. Therefore we can say 0 0 0 belongs to W. Therefore we can say W is non-empty. Okay, first condition holds, that is the given set is non-empty. Now we consider any two arbitrary elements alpha and beta of W. Let alpha equals to x1 y1 z1 and beta equals to x2 y2 z2. You can consider here alpha equals to a1 b1 c1, beta equals to a2 b2 c2. Then alpha and beta should satisfy the conditions of the set because alpha beta belongs to the set. So the condition is x1 minus 4y1 plus 3z1 equals to 0 and x2 minus 4y2 plus 3z2 equals to 0. Let us take these two conditions and mark this as number A. Now what is the value of alpha plus beta? Alpha plus beta is x1 y1 z1 plus x2 y2 z2. That is x1 plus x2 comma y1 plus y2 comma z1 plus z2. This is our alpha plus beta. Now we have to verify whether alpha plus beta holds the condition of this set or not. To verify it, we have to put the values of x1 plus x2, y1 plus y2, z1 plus z2 in places of x, y, z. So we get x1 plus x2 minus 4 into y1 plus y2 plus 3 into z1 plus z2, that is equals to x1 plus x2 minus 4y1 minus 4y2 plus 3z1 plus 3z2. That is equals to x1 minus 4y1 plus 3z1 within first bracket plus x2 minus 4y2 plus 3z2 another first bracket. This is 0 according to equation number A, and this is also 0 according to equation number A. So 0 plus 0 equals to 0. So we can say alpha plus beta also holds the condition of the set W, that is alpha plus beta belongs to W. So the first condition holds. Let us take this condition as equation number 1. Next condition is we consider C be any real number, so that C alpha equals to C into x1 y1 z1, that is Cx1 Cy1 Cz1. Again we have to verify whether this element belongs to the set or not. To verify it, we verify the condition of the set, that is Cx1 minus 4Cy1 plus 3Cz1. C take as common, x1 minus 4y1 plus 3z1, C, this is our 0. This is our 0. Now C into 0 is 0. So we see that C alpha also holds the condition of the set W. Therefore C alpha belongs to W. This is marked as number 2. So these two conditions are the conditions to be a subset, a subspace, and therefore we can conclude that by equation 1 and 2 W is a subspace of R3. So this is very easy, an interesting one. Next question is a matrix related problem. Show that capital S equals to, here the element is a 2 by 2 matrix belongs to R 2 by 2 such that A plus B equals to 0, means this sum of these two equals to 0. We have to verify whether this is a subset or subspace or not. So this is given. Now again 0 belongs to R and 0 0 0 0 belongs to R 2 by 2 because 0 0 0 0 is a 2 by 2 matrix. Now sum of these two elements equals to 0. So we can say this 0 matrix also holds the condition of this set S. So definitely this 0 element belongs to S. So in other words we can say S is non-empty. This is very important. Okay, first we have to verify whether the set is non-empty or what. We now consider two arbitrary elements alpha and beta of capital S such that alpha equals to A1 B1 C1 D1 and alpha 2 and beta equals to A2 B2 C2 D2. Now we have to find alpha plus beta. First, as alpha beta belongs to the set capital A, so we can say A1 plus B1 equals to 0 and A2 plus B2 equals to 0. Let us mark this as equation number A. Now we have to find alpha plus beta, that is A1 B1 C1 D1 plus A2 B2 C2 D2. This is addition of matrices, that is A1 plus A2 B1 plus B2 C1 plus C2 plus D1 plus D2. Alright. Now alpha plus beta will belong to this set if it holds the condition of this set. So therefore we have to add this and this element, that is A1 plus A2 plus B1 plus B2. Now A1 plus B1 plus A2 plus B2, A1 plus B1 is 0 and A2 plus B2 is also 0. So we can write 0 plus 0 equals to 0. So our first condition holds. Now come to the second condition. Again, we consider C belongs to our set of real numbers such that C alpha equals to C into alpha is A1, B1, C1, D1. Then CA1, CB1, CC1, CD1, right? Now, again, we have to verify whether the element belongs to the set or what. So here, CA1 plus CB1, C taken as common, we have A1 plus B1. Now, A1 plus B1 is nothing but 0. So we can say C into 0 equals to 0 by equation number A. Therefore, as C alpha satisfies the condition of the set capital A, so we can or we have to say that C alpha also belongs to the set capital S. Therefore, the three conditions, actually three conditions. First condition is non-empty, holds, right? Second condition is what? Second condition is alpha plus beta belongs to S, holds. Third condition is what? C alpha belongs to S, holds. So as the three condition holds, we can say that capital S is a subspace of R2. Now the third example related to subspace, here show that S equals to xyz belongs to R3 such that xy equals to z. So this is our condition for this subset. We have to verify whether this is a subspace or what. So first we have to show that this set is non-empty or what. So here 0 belongs to R and 0 0 0 belongs to R3. Also the multiplication of the first two components of 0 0 0 is 0 into 0 equals to 0. That is, this also holds the condition or criteria of the given set. So in other words, we can say 0 0 0 belongs to capital S. That is, S is a non-empty subset, right? Next condition, we consider any two arbitrary elements alpha beta belongs to S such that alpha equals to x1 y1 z1 and beta equals to x2 y2 z2. As alpha beta belongs to S, so we can say x1 y1 equals to z1 and x2 y2 equals to z2. Mark this as equation number 1. Now come to alpha plus beta. What is alpha plus beta? Alpha is x1 y1 z1 plus beta is x2 y2 z2. So x1 plus x2 comma y1 plus y2 comma z1 plus z2. Now we have to verify whether this element satisfy the given condition or what. Xy equals to z. Here x is x1 plus x2 and y is y1 plus y2. Now we have to take the product of these two, that is x1 plus x2 into y1 plus y2, that is x1 y1 plus x2 y2 plus x1 y2 plus x2 y1. So this is our product. Now x1 y1 is what? X1 y1 is z1 according to 1, and x2 y2 is what? X2 y2 is z2 according to 1. So x1 y1 z1 and x2 y2 is z2, but the remaining two is same because we don't know the values of these two. So we cannot write as this z1 plus z2 for all the values of x1 and y1, x2 y2, etc. So we cannot say x1 plus x2 into y1 plus y2 equals to z1 plus z2. That is, in other words, we can say that alpha plus beta does not hold the condition of the given set capital S. Therefore, alpha plus beta does not belongs to S, though alpha comma beta belongs to S. So the main condition or the first condition does not hold. Hence, we say capital S is not a subspace of R3. Okay. So in this way, we can verify whether a given subset is non-empty or what is the subset satisfies the condition or to be a subspace or what. So this video is up to this. In the next video, I will discuss on basis and dimension of a subspace. Thank you.